T-minus 30. T-minus 20.
Stage 1 locks, pressing for flight.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And that's liftoff of Falcon 9. Falcon 9 is clear to tower.
First stage propulsion power. Stage 1 propellant utilization active. Falcon power 29.
Now, as we swap camera angles, while cloud cover may make some of them not visible, the rumble is still audible as Falcon and Dragon ascend through the atmosphere. And we're about to reach supersonic speeds. You'll hear the call out on the net.
MF chill started.
Now the vehicle. Now the vehicle has gone supersonic, which means that it's traveling faster than the speed of sound, greater than Mach 1, which at that altitude is about 750 miles per hour. We have also passed max Q, which is the maximum dynamic pressure that we will experience. From here on out, it's less and less loads on the vehicle as we continue to ascend. Now we're going to come up on 4 events in rapid succession. We'll let those happen and then I'll briefly discuss what they were. But those are MECO, stage separation, second engine start, and then the boost back burn. As you just heard, we had that successful transition from the responsibilities of the first stage to the second stage. Main engine cutoff, stage separation, second stage engine start, and then the boost back burn to bring that first stage back to landing zone 1.
Stage 2 propulsion nominal.
So as you just heard from Brian, it sounds like we had a successful stage separation and a successful light of that second stage engine. That means that the Dragon is currently on its way to the International Space Station.
Now coming up soon, we're going to have a few events coming up in quick succession. We're going to have the nose cone of Dragon deploy. That's at the very top of the spacecraft, protecting it from the aerodynamic pressures and forces during ascent. Once we get into the vacuum of space, we no longer need it, and it's just extra mass, so we will jettison it. After that, the second stage burn will come to a conclusion, and shortly thereafter, Dragon will deploy.
Once Dragon is off on its own, the first thing it does is it's going to extend its solar arrays so we can start gathering that solar energy in preparation for its trip to the International Space Station. Once it has power, it'll also prime its propulsion systems. Dragon has 4 independent propulsion modules, and each of them is capable of thrusting it towards the International Space Station.
Shortly thereafter, the GNC bay door will begin its opening. That's guidance, navigation, and control. bay door will open, and inside of that are all of Dragon's sensors that help us know where it is and help it find the International Space Station. It'll then begin to perform those height adjustment maneuvers and co-elliptic burns that Tom talked about earlier in order to get it up to the exact location at the approach ellipsoid at the International Space Station to begin that process where the Canada arm will begin to grapple the Dragon spacecraft.
And then this is all going to happen over the course of 36 hours from today. Dragon has a long way to go after it separates from that second stage. However, right now, you can see on your screen on the right is that second stage engine nozzle currently burning and thrusting Dragon into a higher orbit. On the left is the first stage. You can see those grid fins deployed. That first stage is currently guiding itself down towards landing zone 1 in Cape Canaveral, Florida.
So we have about 1 minute until our entry burn is going to begin. Now that burn is intended to slow the vehicle down as it re-enters the atmosphere. If you come in down at those super high speeds, you're going to break up the vehicle. So we got to slow it down so that it can actually guide itself more precisely to the location back down at LZ1. Once it gets closer, it'll begin that landing burn, which is the final burn in the 3-burn recovery sequence, where the center engine E9 will ignite and slow the rocket all the way down to 0 velocity.
You can currently see the cold gas thrusters in the left side of your screen. Those are helping to right the vehicle as it gets down further and further into the atmosphere, make sure it's pointed in the correct direction. And then once it gets into the atmosphere, those grid fins are going to start turning, maybe only a little bit, to help guide it through the air as it gets down towards LZ1.
Now, as we get down to LZ1, we have that onboard Falcon camera. And, we have that entry burn coming up in a few seconds. You can probably check it out here. Look on the right, you can see the first stage coming back, and that entry burn has begun. And the entry burn has shut down. And the next burn going to come up shortly thereafter is going to be that landing burn.
So we do have cameras stationed at LZ1. It's a little bit of a cloudy day still there, so we may not see the Falcon 9 first stage come all the way down. We may just catch the very end of it. That landing burn is actually pretty short. It starts only a few hundred meters off the pad. You may not be able to see it all the way down, but we hope we can get some good video.
And when we get that really cool footage, you should be able to see the fire sneak in through the frame. Again, it really depends on cloud coverage and how our tracking cameras are positioned. We could see that, that's a really cool view over to the left side, the onboard camera of Falcon 9. You can see the Earth coming closer and closer.
You can see it's passing through the cloud cover right now. The landing burn is just starting. That's a beautiful shot of that first stage of the camera. Let's watch it go down to the pad. Let's get a status update on how our primary mission is doing.
Another truly amazing landing of the first stage. We're all here very excited at the headquarters, as are those excited wasps that you just saw on your landing zone 1 screen. But let's focus back onto the primary mission now, which is how second stage is performing with Dragon. Now, second stage follows a very different burn profile. 3 burns: the boost back burn, the re-entry burn, and then the landing burn. Second stage only has 1 burn before it actually departs from Dragon. So we're about to come up on that event here in about 30 to 60 seconds or so, and we call that SECO number 1, which stands for second stage engine cutoff number 1. We'll follow through and listen into that, and then we'll discuss the events that will occur thereafter.
SECO 1.
SECO-1 as the glow of that MVAC-D engine fades. Now the next major milestone now that second stage has stopped burning is separation from Dragon itself. It was burning for about 6.5 minutes to get us into the orbit that we need to fire our pyrotechnic devices and gently push Dragon away so that it, as a self-sustaining vehicle, can continue on to the International Space Station of its own accord. So let's listen in for separation of Dragon from second stage here in a moment. Looking at a view of Dragon and second stage separating as Dragon continues solo onto its mission to traverse over the next 64 hours or so to the International Space Station. Now, it's worth reiterating what Dragon's going to be doing over the next few hours. The very first thing we do now that we are separated is we prime the propulsion system. This is when we open those pressurant valves and enable us to fire our propellants so that we can readjust and orient our position out in space. We need to do that so that we can point at the tracking and data relay satellite system first. Once we acquire those ground stations, we can confirm communication with Dragon, which opens the door for all of the events that follow. Now, after we establish TDRS, we do an event called Solar Array Deployment. As Tom mentioned earlier, the solar arrays unfurl from the side of the trunk after their fairings are released. They are doing that so that we can recharge from energy harvested from the sun so that our onboard batteries will last this multi-day journey up to the space station. That solar array deployment occurs at about T plus 10, 11, 12 minutes or so that will come up soon, and we will provide coverage of that deployment. Now, after we close out the webcast, a few events will happen thereafter, and they are worth noting, and that is the opening of the GNC bay door next at about T plus 2 hours. GNC, as Lauren mentioned, stands for Guidance, Navigation, and Control, and that bay houses all of our sensors that we need for close proximity ops with the International Space Station. LiDARs, laser detection and ranging, thermal imagers, GPS units, star trackers, etc., so that Dragon continually knows both where it is and how it's oriented. That's very important once we get close to the ISS. Now, after that GNC bay door opens at about T plus 2 hours, we then begin those slew of burns, the height adjusts and the co-elliptic burns that we need to go all the way up to the International Space Station as we inch closer and closer along that staircase to the International Space Station. Once we're there, we berth, we get captured, the astronauts offload all the cargo, we stay up there for about a month, and then we return about a month later with return cargo, splash down with attempts to refly that same Dragon again later at some point. So now we're coming up on Solar Array Deploy, that event that I mentioned a few moments ago, so let's watch that now. And there you have it, as the wings of Dragon extend slowly out from the passive springs from the trunk so that we can harvest energy from the sun over the next 2.5 days as we journey up to the space station. It has been a wonderful timeline so far for this very first reflown Dragon. Best of luck and continue on to your mission to the International Space Station.
And with that, we are coming to a close on our webcast. It's been a successful day for SpaceX, starting with Falcon 9, a successful launch of the first stage and the second stage as well, with the second stage taking Dragon to its intended orbit, and stage 1 returning to land for our 5th successful on-land recovery. And Dragon has had a wonderful start to its mission. The first reflown Dragon is now in space on its own accord. Its solar panels are deployed, and it's beginning the process of its extended mission.
So like we've been saying, Dragon's journey is going to take about 36 hours to complete to get to the ISS. Please follow along with all of our media channels to follow along with exactly how Dragon's doing. We'll be keeping you as up to date as we can. We'd like to thank NASA for being our partner in these resupply missions, now the 11th that we've flown. We'd like to thank the Air Force and the Range for supporting our launch today from Kennedy Space Center. And we'd like to thank you, the viewers, for tuning in. Thanks for watching yet another successful SpaceX launch.